Coronae Borealis is a small constellation in the Northern Celestial Hemisphere. It is one of the 48 constellations listed by the 2nd century astronomer Ptolemy, and remains one of the 88 in modern constellations. Its brightest stars form a semicircular arc. Its Latin name, inspired by its shape, means northern crown. In classical mythology, Coronae Borealis generally represented the crown given by the god Dionysus to the Cretan princess Ariadne and set by him in the heavens. Other cultures likened the pattern to a circle of elders, an eagle's nest, a bear's den, or even a smoke hole. Ptolemy also listed a southern counterpart, Coronae Australis, with a similar pattern. The brightest star is the magnitude 2.2 Alpha Coronae Borealis. The yellow supergiant arc Coronae Borealis is the prototype of a rare class of giant stars, the arc Coronae Borealis variables, that are extremely hydrogen deficient, and thought to result from the merger of two white dwarfs. T Coronae Borealis, also known as the blaze star, is another unusual type of variable star known as a recurrent nova, normally of magnitude 10. It last flared up to magnitude 2 in 1946. Adds 9731 and Sigma Coronae Borealis are multiple star systems with 6 and 5 components respectively. 5 star systems have been found to have Jupiter-sized exoplanets. Able 2065 is a highly concentrated galaxy cluster 1 billion light-years from the Solar System, containing more than 400 members, and is itself part of the larger Coronae Borealis supercluster. Characteristics: covering 179 square degrees and hence 0.433% of the sky. Coronae Borealis ranks 73rd of the 88 modern constellations by area. Its position in the Northern Celestial Hemisphere means that the whole constellation is visible to observers north of 50 degrees south. It is bordered by Bootes to the north and west, Serpens Caput to the south, and Hercules to the east. The three-letter abbreviation for the constellation, as adopted by the International Astronomical Union in 1922, CRB. The official constellation boundaries, as set by Eugene Delporte in 1930, are defined by a polygon of 8 segments. In the equatorial coordinate system, the right ascension coordinates of these borders lie between 15 hours 16.0 minutes and 16 hours 25.1 minutes, while the declination coordinates are between 39.71 degrees and 25.54 degrees. It has a counterpart, Coronae Australis, in the Southern Celestial Hemisphere. Notable features: stars. The 7 stars that make up the constellation's distinctive crown-shaped pattern are all 4th magnitude stars except for the brightest of them, Alpha Coronae Borealis. The other 6 stars are Theta, Beta, Gamma, Delta, Epsilon and Iota Coronae Borealis. The German cartographer Johann Bayer gave 20 stars in Coronae Borealis bio-designations from Alpha to Epsilon in his 1603 star atlas, Uranometria. Zeta Coronae Borealis was noted to be a double star by later astronomers, and its components designated Zeta 1 and Zeta 2. John Flamsteed did likewise, with New Coronae Borealis, classed by Bayer as a single star. It was noted to be 2 close stars by Flamsteed. He named them 20 and 21 Coronae Borealis in his catalogue, alongside the designations Nu 1 and Nu 2 respectively. Chinese astronomers deemed 9 stars to make up the asterism, adding Pi and Rho Coronae Borealis. Within the constellation's borders, there are 37 stars brighter than or equal to apparent magnitude 6.5. Also called Alpheca Gemma. Alpha Coronae Borealis appears as a blue-white star of magnitude 2.2. In fact, it is an algal-type eclipsing binary that varies by 0.1 magnitude with a period of 17.4 days. The primary is a white main sequence star of spectral type AOV that is 2.91 times the mass of the Sun and 57 times as luminous, and is surrounded by a debris disk out to a radius of around 60 astronomical units. The secondary companion is a yellow main sequence star of spectral type G5V that is a little smaller the diameter of the Sun, lying 75 plus or minus 0.5 light-years from Earth. Alphecca is believed to be a member of the Ursa Major moving group of stars that have a common motion through space, located 112 plus or minus 3 light-years away. Beta Coronae Borealis Nu Sarkhan is a spectroscopic binary system whose two components are separated by 10 astronomical units and orbit each other every 10.5 years. The brighter component is a rapidly oscillating up star pulsating with a period of 16.2 minutes, of spectral type A5V with a surface temperature of around 7,980 K. It has around 2.1 m, 2.6 solar radii, and 25.3 L. The smaller star is of spectral type F2V with a surface temperature of around 6,750 K, and has around 1.4 m, 1.56 R, and between 4 and 5 L. Near Nu Sarkhan is Theta Coronae Borealis, a binary system that shines with a combined magnitude of 4.13 located 380 plus or minus 20 light-years distant. The brighter component, Theta Coronae Borealis A, is a blue-white star that spins extremely rapidly, at a rate of around 393 kilometers per second. A B star, it is surrounded by debris disk. Flanking Alpha to the east is Gamma Coronae Borealis, yet another binary star system, whose components orbit each other every 92.94 years and are roughly as far apart from each other as the Sun and Neptune. The brighter component has been classed as a delta Scuti variable star, though this view is not universal. The components are main sequence stars of spectral types B9V and A3V, located 170 plus or minus 2 light-years away. 4.06 magnitude. Delta Coronae Borealis is a yellow giant star of spectral type G3.53 that is around 2.4 m and has swollen to 7.4 R. It has a surface temperature of 5,180 K. For most of its existence, Delta Coronae Borealis was a blue-white main sequence star of spectral type B before it ran out of hydrogen fuel in its core. Its luminosity and spectrum suggest it has just crossed the Hertzsprung gap, having finished burning core hydrogen and just begun burning hydrogen in a shell that surrounds the core. Zeta Coronae Borealis is a double star with two blue-white components 6.3 arcseconds apart that can be readily separated at 100x magnification. The primary is of magnitude 5.1 and the secondary is of magnitude 6.0. Nu Coronae Borealis is an optical double, whose components are a similar distance from Earth but have different radial velocities, hence are assumed to be unrelated. The primary, Nu 1 Coronae Borealis, is a red giant of spectral type M2II and magnitude 5.2, lying 640 plus or minus 30 light-years distant, and the secondary, Nu 2 Coronae Borealis, is an orange-hued giant star of spectral type K5II and magnitude 5.4, estimated to be 590 plus or minus 30 light-years away. Sigma Coronae Borealis, on the other hand, is a true multiple star system divisible by small amateur telescopes. It is actually a complex system composed of two stars around as massive as the Sun that orbit each other every 1.14 days, orbited by a third Sun-like star every 726 years. The fourth and fifth components are a binary red dwarf system that is 14,000 astronomical units distant from the other three stars. Add 9,731 as an even rarer multiple system in the constellation, composed of 6 stars, 2 of which are spectroscopic binaries. Coronae Borealis is home to 2 remarkable variable stars. T Coronae Borealis is a cataclysmic variable star also known as the blaze star. Normally placid around magnitude 10, it has a minimum of 10.2 and maximum of 9.9. It brightens to magnitude 2 in a period of hours, caused by a nuclear chain reaction and the subsequent explosion. T Coronae Borealis is one of a handful of stars called recurrent novae, which include T Pyxides and U Scorpii. An outburst of T Coronae Borealis was first recorded in 1866. Its second recorded outburst was in February 1946. T Coronae Borealis is a binary star, with a red-hued giant primary and a white dwarf secondary, the two stars orbiting each other over a period of approximately 8 months. Our Coronae Borealis is a yellow-hued variable supergiant star over 7,000 light-years from Earth, and prototype of a class of stars known as our Coronae Borealis variables. Normally of magnitude 6, its brightness periodically drops as low as magnitude 15 and then slowly increases over the next several months. These declines in magnitude come about as dust that has been ejected from the star obscures it. Direct imaging with the Hubble Space Telescope shows extensive dust clouds out to a radius of around 2,000 astronomical units from the star, corresponding with a stream of fine dust associated with the star's stellar wind and coarser dust ejected periodically. There are several other variables of reasonable brightness for amateur astronomer to observe, including 3 Mira-type long-period variables. S Coronae Borealis ranges between magnitudes 5.8 and 14.1 over a period of 360 days. Located around 1946 light-years distant, it shines with a luminosity 16,643 times that of the Sun and has a surface temperature of 3,033 K. One of the reddest stars in the sky. V Coronae Borealis is a cool star with a surface temperature of 2,877 K that shines with a luminosity 102,831 times that of the Sun and is a remote 8,810 light-years distant from Earth, varying between magnitude 6.9 and 12.6 over a period of 357 days. It is located near the junction of the border of Coronae Borealis with Hercules and Bootes, located 1.5 degrees northeast of Tau Coronae Borealis. W Coronae Borealis ranges between magnitude 7.8 and 14.3 over a period of 238 days. Another red giant, R Coronae Borealis, is a M3-type semi-regular variable star that varies between magnitude 7.3 and 8.2 over 60.8 days. RS Coronae Borealis is yet another semi-regular variable red giant, which ranges between magnitudes 8.7 to 11.6 takes over 332 days. It is unusual in that it is a red star with a high proper motion. Meanwhile, Coronae Borealis is an algal-type eclipsing binary star system whose magnitude varies between 7.66 and 8.79 over a period of 3.45 days. Coronae Borealis is a pulsating white dwarf type, which is around 70% as massive as the Sun, yet has only 1.1% of its diameter. Discovered in 1990, Coronae Borealis is a low-mass X-ray binary system composed of a star less massive than the Sun and a neutron star surrounded by an accretion disk that draws material from the companion star. It varies in brightness in an unusually complex manner. The two stars orbit each other every 111 minutes, yet there is another cycle of 112.6 minutes, which corresponds to the orbit of the disk around the degenerate star. The beat period of 5.5 days indicates the time the accretion disk, which is asymmetrical, takes to process around the star. Extrasolar planetary systems. Extrasolar planets have been confirmed in 5 star systems, 4 of which were found by the radial velocity method. The spectrum of Epsilon Coronae Borealis was analyzed for 7 years from 2005 to 2012, revealing a planet around 6.7 times as massive as Jupiter, orbiting every 418 days at an average distance of around 1.3 astronomical units. Epsilon itself is a 1.7 m orange giant of spectral type K2II that has swollen to 21 R and 151 L. Kappa Coronae Borealis is a spectral type K1IV orange subgiant nearly twice as massive as the Sun. Around it lie a dust debris disk, and one planet with a period of 3.4 years. This planet's mass is estimated at 2.5 megajoules. The dimensions of the debris disk indicate it is likely there is a second substellar companion. Omicron Coronae Borealis is a K-type clump giant with one confirmed planet with a mass of 0.83 megajoules that orbits every 187 days, one of the 2 least massive planets known around clump giants. HD 145,457 is an orange giant of spectral type KOII found to have one planet of 2.9 megajoules. Discovered by the Doppler method in 2010, it takes 176 days to complete an orbit. X01 is a magnitude 11 yellow main sequence star located approximately 560 light-years away, of spectral type G1V with a mass and radius similar to the Sun. In 2006, the hot Jupiter exoplanet X01b was discovered orbiting X01 by the transit method using the exotelescope. Roughly the size of Jupiter, it completes an orbit around its star every 3 days. The discovery of a Jupiter-sized planetary companion was announced in 1997 via analysis of the radial velocity of Rho Coronae Borealis, a yellow main sequence star and solar twin of spectral type GOV, around 57 light-years distant from Earth. More accurate measurement of data from the Hippocos satellite subsequently showed it instead to be a low-mass star somewhere between 100 and 200 times the mass of Jupiter. Possible stable planetary orbits in the habitable zone were calculated for the binary star Theta Coronae Borealis, which is composed of 2 stars, yellow main sequence stars of spectral type G1V and G3V respectively, similar in mass and spectrum to the Sun. No planet has been found, but a brown dwarf companion about 63 times as massive as Jupiter with a spectral type of L8 was discovered at a distance of 3,640 astronomical units from the pair. In 2001, Deep sky objects. Corona Borealis contains few galaxies observable with amateur telescopes. NGC 6085 and 6086 are a faint spiral and elliptical galaxy respectively, close enough to each other to be seen in the same visual field through a telescope. Able 2142 is a huge X-ray luminous galaxy cluster that is the result of an ongoing merger between two galaxy clusters. It has a redshift of 0.0909 and a visual magnitude of 16.0. It is about 1.2 billion light-years away. Another galaxy cluster in the constellation RxJ1532.9 plus 3021 is approximately 3.9 billion light-years from Earth. At the cluster's center is a large elliptical galaxy containing one of the most massive and most powerful supermassive black holes yet discovered. Able 2065 is a highly concentrated galaxy cluster containing more than 400 members, the brightest of which is 16th magnitude. The cluster is more than 1 billion light-years from Earth. On a larger scale still, Able 2065, along with Able 2061, Able 2067, Able 2079, Able 2089, and Able 2092, make up the Corona Borealis supercluster. Another galaxy cluster, Able 2162, is a member of the Hercules superclusters. Mythology. In Greek mythology, Corona Borealis was linked to the legend of Theseus and the Minotaur. It was generally considered to represent a crown given by Dionysus to Ariadne, the daughter of Minos of Crete, after she had been abandoned by the Athenian prince Theseus. When she wore the crown at her marriage to Dionysus, he placed it in the heavens to commemorate the wedding. An alternate version has the besotted Dionysus give the crown to Ariadne, who in turn gives it to Theseus after he arrives in Crete to kill the Minotaur that the Cretans have demanded tribute from Athens to feed. The hero uses the crown's light to escape the labyrinth after disposing of the creature, and Dionysus later sets it in the heavens. The Latin author Hyginus linked it to a crown, a wreath worn by Bacchus to disguise his appearance when first approaching Mount Olympus and revealing himself to the gods, having been previously hidden as yet another child of Jupiter's trysts with a mortal, in this case Semele. In Welsh mythology, it was called Caer Arianrhod, the castle of the Silver Circle, and was the heavenly abode of the Lady Arianrhod. Corona Borealis was one of the 48 constellations mentioned in the Almagest of classical astronomer Ptolemy. The Arabs called the constellation Al-Feka, which means separated or broken up, a reference to the resemblance of the stars of Corona Borealis to a loose string of jewels. This was also interpreted as a broken dish. Among the Bedouins, the constellation was known as Qasat al-Masakan, or the dish bowl of the poor people. The Skidi people of Native Americans saw the stars of Corona Borealis representing a council of stars whose chief was Polaris. The constellation also symbolized the smoke hole over a fireplace, which conveyed the messages to the gods, as well as how chiefs should come together to consider matters of importance. The Shawnee people saw the stars as the heavenly sisters, who descended from the sky every night to dance on earth. Al-Feka signifies the youngest and most comely sister, who was seized by a hunter who transformed into a field mouse to get close to her. They married, though she later returned to the sky with her heartbroken husband and son following later. The MIKMAQ of eastern Canada saw Corona Borealis as Mskegwom, the den of the celestial bear. Polynesian peoples often recognized Corona Borealis. The people of the Tuamotus named it Nakauikitokara and probably Tehatu. The constellation was likely called Kauamea in Hawaii, Rong of Whenua in New Zealand, and Te Wailoawitu in the Cook Islands atoll of Pukepuka. Its name in Tonga was uncertain. It was either called Dao Ouvea or Kaukupenga. In Australian Aboriginal astronomy, the constellation is called Woomera due to the shape of the stars. The Whalewoon people of northwestern New South Wales saw Corona Borealis as Mully and Walleye, eagle's nest, with Altair and Vega, each called Mully, and the pair of eagles accompanying it. The Waterman people of northern Australia held the constellation to be a gathering point for men's law. Women's law and law of both sexes come together and consider matters of existence. Later references. Corona Borealis was renamed Corona Fermiana in honor of the Archbishop of Salzburg in the 1730 Atlas Mercuriae Philosophicae Firmamentum Firminianum, Descriptionem by Corbinianus Thomas, but this was not taken up by subsequent cartographers. The constellation was featured as a main plot ingredient in the short story Hypnos by H. P. Lovecraft, published in 1923. It is the object of fear of one of the protagonists in the novella. Finnish band Cadacross released an album titled Corona Borealis in 2002.